In this presentation, we're going to cover a couple of different things, a couple of different programming languages, and some of the nitty-gritty but yet very powerful aspects of the FEMAP API. These are things that the average user might not know or necessarily need on a day-to-day basis, but when you get the power users that come in and talk about their own add-in applications, or they want to control very specific events in FEMAP, or they want to make add-in products on top of FEMAP, these are the kinds of things that we spend some time to really give you the tools to do everything under the sun. So without further ado, this is kind of the outline of what we're going to talk about today. I'm going to talk about a brief introduction of what the FEMAP API is. Most of us are probably familiar, but we'll talk a little bit about its role with Microsoft COM and other programming languages. We're going to talk about events in FEMAP, both the event callback mechanism and as well as trapping external messages in your own add-in applications. We're going to talk about some relatively new functionality where you can actually automate multiple running instances of FEMAP at the same time. You could be doing different model setups. You do transferring of data between different models and even between Excel and your own application. We're going to do some live demos here and show just kind of how simple and easy it is to set some of these things up as well. I will dwell a little bit on Python because it's becoming a very popular programming language, especially among engineers. And then we're going to wrap up with a really cool example that is a C++ DLL that really was to the benefit of NASA in a most recent project where they had spectacular results. So let's get right into the introduction. The FEMAP API stands for Application Programming Interface, and that is just a blanket term for any software that exposes its methods through any kind of mechanism. Today you'll hear about REST or SOAP or some of these other online APIs. Kind of all of it started with Microsoft COM and Cobra and stuff back in the 90s and 80s where you had these architectures that were basically just between applications on a desktop, and that's what FEMAP really excels at, no pun intended. So COM is a software architecture that promotes language independence and code reuse. Because of this, we're able to access functions and methods that are published by any automation server. And an automation server is FEMAP in most cases. It can be Microsoft Excel, it can be Word, it can be even a DLL. So the cool thing is that FEMAP can both act as a client and a server. And in most instances, we are writing applications or we are writing code as a client. And a client can be written in any programming language that is COM accepting. It can subscribe to the binary layout of COM and be written in Python, C, C++, C#, Delphi, MATLAB, really any programming language that you prefer and can recognize COM, you can talk to FEMAP and start writing your own programs with. So I took a little code snippet here of, what is the easiest way to get up and running in the FEMAP API? Well, in the FEMAP API pane, we use Visual Basic. We use a derivative of it called WinRAP Basic, but they're essentially the same. FEMAP Basic is here on the left, and Python is here on the right, and with virtually the same number of lines of code, we can do very similar things. So both Basic and Python are very readable, and that's, I think, why engineers prefer to use that. They don't use a lot of memory management or any kinds of intense management of resources. It's just up and running and out of the box, and it just works. So we're going to kind of go beyond this, and we're going to talk about how I can start using events in some applications that I can develop in FEMAP and outside of it. So for those who don't know, FEMAP offers a mechanism called the event callback. This is a very powerful, often overlooked tool in our API. I've personally answered support questions from the HEEDS team development that utilizes this mechanism. Many users on the forum have come across this and been really delighted to find that what you can do is tell FEMAP essentially to perpetually call your script. It can perpetually call your .bas script, or it can even call an external executable. So, one popular event is when a analysis is finished completing. You could actually tell FEMAP that once that event has been triggered, you want to call a script that either prints something to the messages pane, maybe it fires up another application, or it even could continuously run further analyses, so that if you were to have a large nonlinear job or some kind of dynamics work that you traditionally would run overnight, you could actually run this. You could run them in tandem, and you would actually have to be there live to do it. So we're going to start with a simple example here. We're going to do a example of the event callback, and then we're going to show kind of that more useful example of doing an analysis. So I've got a couple of models open here, and I'm going to go right into opening my programming pane. So I go to Tools, Programming, API Programming. And I've got some pre-written scripts here, but I'll show you just how quick it is, how little lines of code it is. So with about 15 lines of code here, I've got my event callback mechanism. And what I'm doing is I'm going to trigger an event that every time any command in FEMAP is run, it's going to call another script that I've got in the same directory called print the event number. So when I run this, I hit the dialog box that I've programmed in, and I say print the event number. And so automatically we've started printing things because these are in themselves commands that are being clicked into this pane. What I can do is I can trap certain events. So what I've done is I've trapped the model info refresh command. So when I hit that model info refresh command, I've used that as a way to kind of go off and do something special. So what I can really capture is when I come through my event callback, this is the other script that's being called every time a command is run. I'm trapping that event number, and I'm printing or I'm running additional code that is only when that command is run. So I had users doing this from Python. I have people that have done this in HEADS. So this is just a really quick example of what the event callback does. So when I set it in this mechanism here, every time a command is run, we will call the program at this path. And that path could be another script, or it can be an executable. And then when I want to turn it off, I just make sure that I'm passing in an empty string so it knows not to call anything. So printing messages is all well and good, but kind of a flashier example is something FEMAP already ships in our custom tools, event callback, start loop. So I can open the script and show you this, but essentially what this does is it iterates the thickness of a shell property as you run each analysis on a new thickened shell. So I'm going to choose my upper wing skin here, and I'm going to just arbitrarily contrive this example to go from a thickness of 1 to a thickness of 6 with 3 different iterations. And as soon as I press OK, this script is going to fire an analysis, and without me having to do any additional work, it's going to thicken that shell property. So you can see I'm refreshing to show you what's being thickened. And it's going to read those results back in. And we've thickened again. So we've got one run coming through. And I'm thickened again. And then finally it should do a third run. So we've gotten 3 runs out of that because I told it to do 3 different iterations going from a thickness of 1 to 6. And so it's a quick way in this model to show how you can run multiple analyses, but it's also a way, as I said, that if you had something that you don't really know how long it's going to run, perhaps it's a very intense contact problem or it's a very intense nonlinear problem, you have to run that overnight, but you wanted to run 3 different instances of it, and it's going to take 3 hours per run. Well, here's the mechanism that you could really use to kind of do that easy, knowing you'll have all of your analyses completed in the morning. So that's kind of a example that we've seen before and we've demonstrated before on the FEMAP team, but something that I think is talked a little bit less often about is message trapping. So this is another way that FEMAP exposes its commands and its notifications to other applications, and this goes into the realm of starting to develop your own add-in applications. So here I have a pre-written program that does some message trapping, and I'll show you the code in a second. What you'll see is that when this pane is added into FEMAP and I've registered the messages to be trapped in my application, everything that I do that is sent to the messages pane is also sent to my application. So this receives commands like text from the messages window. You can receive commands like the resizing of the FEMAP GUI. You can receive other commands like we just saw with the event interface. So this is just another layer on top of the event callbacks that we have to really sharpen your tools as a developer to grab information from FEMAP and maybe lay on top of it or interact and go off and do something else. So I will open that up and I'll kind of show you just how more or less trivial the code looks in that. I've written this in VB.NET, which is the .NET platform version of Visual Basic. They're very much the same. VB.NET is much more powerful, but syntactically it is the same. I've done this for simplicity, but you can of course write this in C# or F# or whatever other language you want. I've done this because it makes it very easy to trap events and use the message handling here. So this is the GUI. I've designed it in Visual Studio. What I do is if I run this application, it will open up this GUI here that I've designed, and when FEMAP is open, what I've programmed this application to do is as soon as I hit this capture button, it should jump into FEMAP, and so now I can start listing info, and I've run a command, and we can see that my application has trapped all the things that I've done here. So, really cool, powerful technology here. This is going to trap all of the things that I send to the messages window. It's not programmed to do much else than that, but this is a really kind of a quick and dirty example of how to start writing applications in this way. As soon as I hit release, it's going to unregister itself, it's going to end its program, and so then we see it jumps back into Visual Studio. So that's a cool example of the FEMAP message trapping. I've made that available on my GitHub page. We also have resources on the FEMAP forum that have stored code like this. I'll make sure to share this with the group for those who are interested in. All of the programs that I'm going to be talking about here are available on my GitHub page. So it's github.com/RYCAT44. But that is one of my more interesting projects that I've worked on, and I really enjoyed getting running because Visual Studio, especially the more modern Visual Studios, really make it easy to do that. Before there was a lot of Windows procedures and things like that. I can save that for a question if anybody has further questions on that. So a new technology that's native into FEMAP, but also plays into writing your own applications, is our ability to do multiple FEMAP automations. So here's kind of a video I put in to really show you a flashy example of what I'm talking about. In 2020.2, we've added code to control multiple running instances of FEMAP, and this is a very specific solution for those who are familiar with any kind of application writing, maybe writing from Excel or from Visual Studio. There was a limitation in the Microsoft technology in terms of attaching to other applications. You could only ever attach to the first running instance of that application. But we've actually overcome that limitation, and so now you as the developer can actually control or look for multiple instances of FEMAP running on your machine. I will note that this was introduced in FEMAP 2020.2. It is only forward compatible because that FEMAP and every forward FEMAP has the code to recognize that. So you can only go forward with this technology, but it's there and it's here to stay. So here's kind of why you would do this. I had a question from a customer asking me about creating an application much like this one that was more or less a controller or a director of the different FEMAP applications on the end user machine. So you can see here what this does is it recognizes that not only are there 2 different FEMAPs running, but there are 5 models open on this machine, and it's listed their model names and it's giving you the process IDs. And I'll fire this up in kind of a live demo as well. You'll see that if I have 2 FEMAPs running here, and I've got this first FEMAP here, and I've got another FEMAP here, traditionally you would only ever be able to attach to the first FEMAP that had started, but with this new technology, what we can do is we can attach to both of those FEMAPs. So if I run this application, and I'll get Visual Studio out of the way, what this has done right on startup is it's detected that I've got my bracket assembly, my ISS model, my 3 million elements up in this FEMAP, and it's also got the other 2 FEMAPs, the other 2 models open here, my enforced rotation and my wing post. And what I can do is if I click on one of my model names and I say connect, you'll see it prints to this FEMAP. If I connect to my wing post FEMAP, which is this one right here. You'll say I print with the process ID here. This application doesn't do much more than that. Some of you may have seen a demo where I used this application to attach to the given FEMAP that was used in some of the What's New release videos. This, of course, as soon as you jump into this connect button, you could go off and attach a pane. You can do whatever else you want. Get information from here, get information from here, maybe do some reporting. Really, the choice is yours as a developer, but the important point is that you now have that ability to use that technology. So that's also available in the API pane. You can do it from a FEMAP. You don't have to do external application development to be able to use that. But that it's a cool way to kind of show that you as a developer can use that. One specific example that I'll touch on for this of why this is significant is FEMAP is a under the hood technology for Solid Edge and all of the finite element work that they do on their CAD interface with FEMAP. They end up kind of dealing with this in a difficult way because of this limitation. They really have no choice but to force the user to close all of their running instances of FEMAP if they want to then use Solid Edge for any kind of simulation work. And that's due to the Microsoft limitation. So going forward, once Solid Edge, and I'm working with the Solid Edge team, once that's integrated completely on their end, this actually won't be a limitation. So you can think of a user having an open application that they're doing work on in FEMAP and they want it to run, a CAD-centered simulation on Solid Edge. Well, they'd have to close their FEMAP work and wait and go back and forth. That shouldn't have to be a limitation anymore. All right, so moving into Python, I'm going to spend probably most of my time here just because this is becoming the most popular programming language in use by developers and engineers alike. It's really shooting past Java. It's beyond C++. It's beyond MATLAB. It's Python everywhere. And for better or worse, I think it's here to stay for a little while. So we might as well use it and use it to our advantage. So I will say that we have spent some time on the FEMAP team developing Python documentation as well as publicly available Python code snippets and how to set up Python before. So what I will talk about, I will cover some of that, but this, of course, also exists in our community forum. We have a nice write-up. We have write-ups about writing FEMAP in Python. We have it on C#. We have it on C++. So what we said in the beginning, as long as a language can recognize COM, you can talk to FEMAP with it. And if you really like Python, it's really a short couple of steps to get up and running and then start running your Python scripts with FEMAP. So to get set up on Python, the first thing you'll do is go to python.org or any organization that you're able to download the Python interpreter and the Python executing module. Python maintains two major branches as a language. There's Python 2 and there's Python 3. You can go on any forum and read the debates about which one's better, but for the purposes of FEMAP and for this demonstration, we're going to be living in Python 3 exclusively. In fact, Python 2 expired in 2020, so Python 3 has more or less migrated all of the technology from Python 2. If not, it probably will in the near future. So Python 3 is the one you probably want to go with, unless you have a specific reason for Python 2. Python 2 and Python 3, of course, are both compatible with COM with a little setup, but Python 3 is probably the one you want to go if you've not gotten any of them. So what you'll do is you'll go to python.org or some other body, and you'll come and you'll try to start downloading whichever version of Python you want. So if you go to the download section, you can see, right now Python 3.8.3 is out. If I go to just the Windows section, we can see that there's many, many different kinds. So you can download something like the executable web installer. So you grab one of these Pythons. That's kind of the easy part. The next part to start talking to FEMAP is to install the Win32 COM client. So this is what we need to actually get up and start writing COM scripts with Python. So Mark Hammond is one of the original developers of Python programming languages. He maintains GitHub repository of this. So if I go into his GitHub repository, we can see he's got releases for all of the PyWin COM modules here. So even the latest release 3.9, which is still in beta for Python, he has that. So you come in and you would click one of the stable releases. You want to make sure that you've downloaded the right bittedness. So you want to make sure you have if you're running 64-bit, you want to download the 64-bit. If you're running Python 3.8, you want to run Python 3.8. So once you download that, you're going to install it. You're going to let it install as admin, and you're going to have this module ready to go on your computer. And then there's one final step to make your life easier, which is to create a Pythonic version of the FEMAP type library. And for those who are unfamiliar, the FEMAP type library is the short way to say it is it's an easy way to get IntelliSense and easy code writing capabilities in your applications. So when you click, FESet dot and you see add and add rule and all the methods pop up, that's done via the type library. So if we want that same ability in Python, we've got to make a Pythonic version of that type library. So what we're going to do is we're going to open a Python interpreter. That can be the one that comes with it, which is IDLE, it could be PyWin, PyCharm, Visual Studio Code. I actually do most of my Python coding in Visual Studio Enterprise Edition, but for this presentation we'll use the native Python IDE. So this is the Python IDE, IDLE that comes with your installation. So what we would do is we would have a script much like this one, and we have this few lines of code, and this is available in that write-up. It's also shown pretty easily here. We do a command called makepy, which converts the FEMAP type library. So we're pointing to a FEMAP type library file here, the TLB, in our FEMAP folder, and it's going to create this file called pyfemap.py. So what I'll do is I will open the directory where this is going to create that file, and you see I've already done it. So what I'll do is I will delete this file, and then we will run this code, and you'll see pyfemap showed up right there. So what this presentation is saying, and what we'll touch on in a second, is that we're going to move this to the library folder. And this might seem like an arbitrary reason, but you need to do this to put Python in your path. And I've already done that. I've put this in my library folder, but for now I'm just going to delete that because I don't need it. Actually, I'll keep it there because we're going to look inside of it. So if we look inside, what we'll find is basically a Pythonic transcription of the type library. So it takes all of the interfaces and COM classes and exposed methods and enums and FEMAP objects, and it maps them to dictionary objects, and it does all the work for us to look up, what are these methods. So when you're using a FEMAP set object, when you're using a FEMAP read object, you can use that in Python thanks to this pyfemap library. So let's go back and we'll just kind of quickly look at that self-generating code from that command. So if we open that up in a program like Notepad++, you can see this is a pretty hefty file, but if you scroll through it, you'll recognize things right away. You'll recognize, FEMAP things like mastering commands, delete commands. These are all Pythonic functions that are mapping those COM calls through this type library, this Pythonic version of the type library. So here's all the FEMAP methods, and it's a really nice tool to do the work for you. So let's go right into a Pythonic example. We'll talk about the basics and why you would even be writing code in Python. Python's just easy to read, pure and simple. It is case sensitive, so you can't avoid capitalization like you can in BASIC. But you never have to specify a variable type. When a string is on the right side of the equal sign, it automatically interprets that as a string. When you change it to a decimal place, it changes it automatically. There's no dimming that you have to do. There's no variable allocation. It does it on the fly. There's no curly braces, no semicolons. You're just going to indent. You can see one of the things and other programmers like about Python is things like list comprehension and really good adding libraries that does matrix multiplication very quickly and easily. Of course, like NumPy and Matplotlib and all of these wonderful plotting tools that Python gives you. Even interfacing with Excel and other reporting tools is done pretty quickly and easily with Python. Even just from a programming perspective, it does very intelligent function overloading. So you can see here I have just one function that does two things. It can take two integers and then it can add that, or it can take in two strings and it can concatenate that. And I've done it with one function. I've had to do no overloading, no telling it what type of type, no by val or by reference. It just kind of works out of the box. List comprehension is something everybody loves in Python. It's inlining something. You can see there's a lot of things going on here. We can do multiplying something in a for loop within a list, and in an if statement. So all this is one single line of code, relatively readable if you know what you're doing, and we can see that it in one command has done all of this list comprehension and done this math for us. So it can really shrink your scripts down to much more readable, efficient modules if you want to pass them around to customers and do things like that. It's just designed very well, and it's been used a lot by the open source community, so it just gets refined and refined and refined. We got a little messed up on our formatting here, but this is something that I guess is not often talked about in Python, but is relevant for a FEMAP developer. The Python GUI modules are not as native as something like Visual Basic or Visual Studio provides you, but what we got is tkinter, and we have something called PyQt. We also have other methods we can use. We can create GUIs with. There's Kiwi. There's all kinds of Python modules. It really is up to you. But I use PyQt personally because it has a nice drag and drop interface. So unfortunately, I'm being blocked here by this. But what you can see is I can drag a button and I can drag it over here, and I can rename it much like I do in Visual Studio. tkinter is nice if you don't want to do any other installations. It's just out of the box with your Python installation. It is a little more manual work to set it up, but this actually is an example. This purple example comes from our FEMAP documentation, and it does a number factorizer. The code here in this presentation is all available. I'll show you a quick demo of the PyQt in use. So again, I'm going to use the native Python interpreter, and here is this code that was generated from what you can see in the presentation. Most of this code was self-generated by that PyQt, so only my red comments are the ones that were added manually. But this does some very simple things in the FEMAP API. We're just going to do a node move by deform. So if I run this module and I wait for it to load, what I will be able to do is get a GUI to talk to FEMAP and do the same functionality that we have in one of our custom scripts, but I've written it completely in Python. And here it is, off screen. Okay, so this is, I think my scaling is a little off, but we can see what this is going to do is it's just going to move some of my nodes to their deformation, and I'm going to do it on wing post so it's pretty noticeable. I'm just going to bump this up by 50 so we can see it. So as soon as I say OK, it's going to run that code, and it's going to talk to FEMAP, and it's going to move that model, it's going to move all those nodes to their deformed location. That's a popular script that we do ship, but I've written it completely in Python here. So what we talked about is using that PyFEMAP. So I've got PyFEMAP, and I'm using the constants here, FC, so I can do things like fc.normal. I can do, ft_lm with this fc in front of it. So this just gives me nice IntelliSense, nice FEMAP constants. This is the way that we use Python to connect to FEMAP. So it's going to look for the FEMAP CLS ID, which is the string globally unique identifier that basically is what COM does under the hood. If you want to know more about that, we can talk about it in questions. So the bulk of it is the GUI here that was written more or less for me with that add-in application, and definitely working out if you feel like this is something you would want to mix together. Of course, you don't have to write GUI with Python. You can also just write scripts that are very efficient and just run back and forth between FEMAP. You can also use the new technology as long as you're in that newer FEMAPs. So I think that's what I have for Python. Here's just a video demo of what we just talked about. So this is us moving that nodes to the form. So I'll move past this. And so what I'll kind of wrap up with towards the end here is really increasing speed in your FEMAP programs. So one of the things, especially when you're talking about Visual Basic and even Python, is that they are interpreted languages, and that means that each line of code has to be interpreted on the fly. So you don't get the advantage of compiled code that you do with C or C++ or even compiled Python, which is its own topic. So what we can do is mix and match some of the interpreted code and the compiled code. And this is a specific example, but it's a really useful thing for people who have existing scripts, but they know that they want to squeeze out more speed, or they know that they have a limitation in just looping over a large data set, or in performing matrix multiplication, or processing strings, or something that it could take a long time, especially with the overhead of the interpreted languages. So we've got two things here we're going to talk about. The first is a very simple example where we're going to write a for loop in Microsoft Basic, and then we're going to write a for loop in C++, and we're going to time the difference. So what's cool about this example is we can put the C++ DLL into our Visual Basic script. So my script here called fast loop, this is going to start with a loop that runs through every node in the model. So we're going to get all the nodes in the model with this get all array call, and then we're going to do just a very simple mathematical operation. We're just going to multiply every XYZ position by 1.2, just arbitrarily, and we're just going to time this operation. So for every node in the model, there's 3 coordinates, and so you're doing 3 times every node in the model. And this model doesn't have too many nodes in it. It has about 138, but to really showcase this difference in speed, we'll go to a model that has 3 million elements. So this model has over 3 million nodes. It has 3 million elements. And if I were to run this code, I'll clear out my messages window. We're going to grab all the nodes in this model, and so we're going to be doing 3 operations for every node in the model. So we're doing 9 million operations in this for loop right here. So if I run this code and we let it run, it should take not too long, but we can see that we're waiting for this operation to finish. And this is purely just because we're going through the overhead of the interpreted code. So based on my timer here, we can see that took about 11.5 seconds. And that's not terrible, but you can see that if I was doing any kind of more serious operation, if I was doing matrix math on all of these nodes, or if I wanted to do multiple multiplication operations, that 11 seconds can really compound and get much slower. So what I've done is I've precompiled a C++ DLL that will run this code and do the exact same thing, but it will run it in C++. And so I'm going to send this information. I'm going to send all of these nodal coordinates into the DLL that I've compiled, and I've declared it in my code here. So if I run this code and I send it to the DLL, you can that finished almost instantaneously. So we got a 0.02 seconds versus 11 seconds. That's almost a 50 times speed return on using the compiled code. And I will pop over and show you just what that looks like in the C++ world. This is all it is. This is the short, simple amount of code that it took to get that kind of speed improvement. So what we've done is we've called this fast loop. I've got this fast loop comes in here. We pass it the pointer to the array that we've signaled in BASIC, and we do that in BASIC by doing the first entry of the array. So the lower bound of this XYZ array, we're passing in a pointer. So then the DLL knows to find that array in memory. So they go and point to the same direction in memory, and we're going to pass in the upper limit of that, so we know when to stop. And we've just written virtually the exact same for loop, and we're doing the same operation, same mathematical operation, and we're going to send in the results just in this out parameter. And this is a particular way that I've written this code. What's nice about it, and which we'll talk about in the next example, is how you can really bake in a lot of results into the way I've written this code. And we'll talk about that for something we did with NASA. But I just think it's such a easy way to visualize how less than 20 lines of code here have given you an almost 50x improvement in speed. So I'll jump back to the presentation. This was born out of a need from a request we had from NASA, where they use the API very heavily, and they deal with very large data sets, especially with some of the telescopes that they're working on, and some of the FE models and satellites, of course, and all their many multi-element, multi-noded models. They wanted faster matrix multiplication. It was just a limitation that they had. They were very proficient in writing scripts, but they were trying to look for a way to do just faster matrix multiplication. And so calling that C++ DLL, as we just saw, provided a ridiculous speed improvement, just a very significant speed improvement. And the comment was, even on his small subset, the C++ implementation was noticeably faster, so it was very cool for him. I'll show you, there's our fast loop demo. We already moved past that. So we had a 55 times improvement about that. Into the NASA case study. So this is just like we had in the fast loop example. We've got a DLL that we compiled here, but you can see it's got a few more parameters. So what they wanted to do is remove rigid body rotation. So they wanted to subtract out the rigid body rotation of their model. And here's the math. I won't go into the math specifically, but just wanted to show that it's not overly complicated, but it is a few steps. So we initially needed the positions, we needed the displacements, the positions of all the other points, which was point B, and the displacements of all the other points, which are the nodes. We had to do some moment arm. We had to do rotation matrix multiplication. We had to do further subtractions and further multiplications, and then we come all the way down to the displacements at B relative to A. So we get all of this math to get at the actual locations of the other nodes when you subtract out that reference node. So without me talking about it too much, I'll show you what that looks like. Here's the DLL that we sent to NASA, and here's the finished product of what that did in FEMAP. So on the left, we had just a contrived example that we were bouncing back and forth, where we performed an enforced rotation on a beam model, and once the DLL does its work, it speedily removes all of those rigid rotations. And so I can show you that in a live demo as well. So let's go into our enforced rotation model. So what's cool about this example is that we were able to develop a GUI in FEMAP, but also get the speed of the compiled DLL. So this script, it's not the shortest script, but it's also not terribly huge. It's under 330 lines of code, and I'm just going to let it run. And what we do is we pick a reference node. So I'm going to pick the node that we enforce a rotation on, and I'm going to pick the data set that I currently have active. So it's this third rotation result, and we're going to do it for all of the nodes in the model, and we're going to do it. We're going to uncheck the linear. We want to do it on a real rotation, so not small angle approximation. So I run that. We say, again, our time took like almost nothing, and we have that rigid body rotation here removed on that analysis set. So going into the code of what something like that looks like, here's what we have in our presentation. We can see in a similar way, we've given it a pointer to certain arrays in memory that we've gotten through FEMAP. We give it some information that we want to perform, like the upper bound and when to stop. We give it the information like the displacements of the nodes and all the other reference nodes. We can do some scaling based on some of those GUI checkboxes that we saw. Here's where we would do a linear approximation, or here's where we would do a normal approximation. So we can see just pure matrix math happening down here. We can see the math that we saw in the PowerPoint coming through. And then what I wanted to emphasize is that in this model, we baked all the results kind of into one output parameter. So the way that I've written this uses a little bit of COM technology, but it actually is not focused on attaching to FEMAP with COM, but it uses the CCOM variant, which is kind of a cool way to do variance within variance. And I want to just kind of demonstrate what I mean by that by freezing on the return of this DLL. So here's where we call the DLL. We send it information. So we send it the lower bound of our array. So that's giving our DLL the pointer to where that array is in memory. And then what we can do is if we freeze here, so I'll do the exact same thing. I'll pick my third analysis set, and I'll leave the linear on, doesn't matter. So if I drag in my new displacements and I hit next, so now you can see I've returned 0 to 5 variance. And if I look at what those are, what I've done is I've actually created variance within variance. So right here, if I hit the first entry in this array, I actually get another whole array of 0 to 243, and that, of course, is the number of nodes in this model. So all of these have, all of the 1 to 5 are a top-level variant that we've baked into the results so we can return as many results as we want. And this is important because originally in the code that we had sent to NASA, I had given them the first 3, which was T1, T2, and T3 translation, and the engineer at NASA was very easily able to add the results for rotation. So he was able to easily add his rotation relative to those nodes based on the bare bones DLL that I had given him in what we can see here. So just a cool way to bake everything into one variant. You can start really have a limitless number of results that you return through those parameters. Of course, this is not the only way that you can do it. You can actually do it through returning inside the function call. You can give a output parameter inside of your function call if you construct your DLL in such a way. The word of caution I have is that the technology you're seeing here does require certain dependencies in terms of the .NET framework. But if you write it on a machine that's compiled on the one that you're going to be using it on, you will ensure that you have that technology there available. So that is kind of the end of what I have. This code here is available on my GitHub as well. Feel free to contact me for more examples, or go in and play with some of this stuff yourself. Start building your own add-in applications, or share it with end users and customers that have these specific requests. There's a lot of power in the FEMAP API, and it's our job to really put that power in the hands of our customers. So that's all for me. If anybody has any questions, feel free to let me know.